Hello everyone, it's Daily Space Observations and welcome to episode 5 of Space News. Today we're going to take a look at the mysterious case of Betelgeuse. Now, if you have any knowledge of space, you'll probably know what Betelgeuse is, but if you don't, I'll give you a rundown on it. Betelgeuse is the second brightest star in the constellation of Orion and is classified as a red giant. A red giant is a star that's in its final stage of life before it dies, whether it explodes into a massive supernova or turns into a small white dwarf star. Every star will be a red giant, and Betelgeuse is big enough to the point where it will go supernova when it dies, which experts estimate will be any time between now and the next 10,000 years. Now that I've explained the story of Betelgeuse, it's been documented that the brightness of our friendly neighborhood of red giant has been fluctuating quite a bit over the past year or so, and scientists didn't know why. Until now, that is. So, without further ado, let's uncover the Betelgeuse mystery and read this article. An international team of astronomers has released new images of Betelgeuse's surface, taken using the European Southern Observatory's Very Large Telescope. In agreement with ultraviolet Hubble Space Telescope observations, the new research reveals that cosmic dust caused the great dimming of Betelgeuse. The team, led by Miguel Montargis from the Paris Observatory, using complex models of Betelgeuse's photosphere, stellar surface, and how dust affects light to unravel the secrets behind Betelgeuse's changing appearance. Before the great dimming event, Betelgeuse belched out a bubble of gas, probably aided by an enormous convective cell welling up, adding to push material away from the star. Betelgeuse pulsates on a reasonably regular cycle. The star breathes once every 400 days or so, puffing up and then contracting again. It so happens that around the time the gas was ejected, Betelgeuse was swelling up, and by December 2019, the puffed up Betelgeuse was some 300 degrees Celsius cooler than average. The drop in surface temperature led to a temperature drop in its surroundings. The previously ejected gas cloud, now some 12.5 astronomical units away from Betelgeuse, cooled enough to start forming dust rapidly. Once the gas nearest to Betelgeuse had condensed into dust, it shielded the rest of the gas cloud from the starlight, encouraging runaway dust formation, amounting to at least 1/100th of the moon's mass. Cosmic dust is extraordinarily effective at blocking and absorbing optical light, which is why Betelgeuse dimmed once this dust had formed. Eventually, the dust cloud moved out of our line of sight to Betelgeuse, and the red supergiant returned to its typical brightness. This new research is not only important because it explains the great dimming of Betelgeuse, but also because it is direct evidence of evolved stars producing cosmic dust easily and quickly. When it comes to the universe, cosmic dust is essential. Not only is it the building block of terrestrial planets, but it is also crucial for life. And that marks the end of my coverage for Betelgeuse in this video. Now, you're probably thinking that was a pretty short article, and that's because I only read like half of it. The other half is a more detailed version of what I just read. So, if you want a more in-depth coverage of Betelgeuse, then tell me in the comments, and I'll make what I guess would be part 2 to this video, and I'll read the other half. However, I'll still see you in the next video regardless of what it is, and I'll catch you later.